Hello and welcome. This is going to be a very quick introduction to the LNSKey Object Database. The LNSKey Object Database, what it allows you to do is save objects away in a flat file out on your hard drive. It works for mobile, it works for PC, works for Mac. Basically, everything that happens is entirely in code, and there's no DLLs that you need to worry about. So basically in this script that we're going to set up, we have this cube that is in a default location in the top right-hand corner of the screen, and we're going to create a mechanism to save its new location. So we'll manually move the cube over to this location and change its rotation. And that's all the script is going to do. So when we start the script, the cube is going to jump down here, and it'll look as if that was the original starting position of the cube. So what we have is a cube here, and I'll remove this component. It was a previous go at this. We're going to start by creating a script here, simple load save, and we're going to assign the script to this cube. So right now there's nothing inside of this script, and I'm going to load it up here. So in order to implement the functionality of the database, we need to implement an interface called EODB class. The class contains, or this interface contains, 3 properties and 3 methods, and we're just going to implement all 6 of them. By default, when you're dealing with a database, this is simply a reference to an existing database. Since we don't use any references, we're going to create the database inside the script. But normally what you would do is put the database in a static object someplace in your system that you create when you first open up the environment, and this database would then reference that static location. But because we're doing everything in the one script, we'll create the database here. OID and version are created automatically, so this is how you get the OID and version number information. So we'll start by just implementing the class name. Return simple. So in this case, it's pretty obvious that you can use any name that you want. The class name gets stored in the header information for the object. So if you're trying to save space, this is one way to do it, is to keep the class names simple. I won't talk about what the class names are for in this video, other than it's a way of identifying individual object types when trying to search for things. I'll talk about definition in a moment, but let's first encode our save logic. And it's really hard. You just EODB descriptor. You provide this. So this is the class that implements this interface, and you give it a number. So in this case, we're going to use a hard-coded number -5 to indicate this object, and that's it. So that's all you need to do for a save. By convention, anything that is less than 0 is considered a hard-coded value, and it's considered, at least in the documentation, static data. So let's create our database. So we'll have an awake method, and we'll say our database is new EODB and we'll give it a file location. So we're going to store it in this folder. So I just copied the name across, and we'll call it simple. So that means when the application starts up, it'll create a database called simple.db. If you have indexes, it'll create new files with whatever the name of the index is. So for example, if you have an index called name, then you'll have a file in this folder eventually called simple.name, and that contains all the index information for that index. And I'll talk about indexes in a different video. So now we're going to do a start. So in the start method, we're going to say new EODB descriptor -5, and then this. So basically what this will do is it will come in and attempt to find an object numbered -5, and if it can't find it, it will return null. And in this case, it's going to use this. So we need to find discover how to actually use this environment. I'm also going to have, there's a third parameter here called auto create. So I'm going to set this to true. And what this does is if it can't find -5 in the database, it will automatically call this DB save. And then the application starts. So this will be essentially the default location. So that's how you construct an object. So if you have a constructor for a class, you're not implementing mono behavior, you'll have to encode this call here in some way to construct your object. In our update, we're going to call DB save, and we're going to say database commit to file system. So the first command will basically save whatever the current object is away in the database. So the database sits in memory, and then we're going to immediately commit what's ever in memory out to the file system. Normally you wouldn't do this. This is like serious overkill because every update's going to essentially commit to the file system. But we're only committing like 50 bytes. So it's not like a huge amount of I/O. But normally you would have this commit process done in some other scene or some other part of your game that says, okay, I want to do a save game. And that's when you actually commit to the file system. And the last thing we need to do is to do this definition. So this definition method gets called by either this constructor or this constructor. And it basically lays out the structure of your object. So and this is the point where you can create any definition you want. There's no schema that you have to define. There's no tables and columns and object relational mapping. It's basically, here's all the fields you want, and we'll just store them away for you. So it's actually a really simple platform for getting any kind of objects. And you can customize to your heart's content whatever is in definition. But for the purposes of this video, we're just going to do something really simple. We're just going to have two structure commands. So the structure has two parameters, a function that returns some kind of type, and that's referred to as a getter, and then an action that accepts that same type and saves the value. So we're going to just do an anonymous delegate, so an anonymous function, and we're going to say we want to get the game object transform position. So now when we actually request the setter, we now know that we're dealing with a vector 3. So we're going to pass in A, which is going to be a vector 3, and to set it, we say game object transform and position equals A. So that's how we do our setters and getters with just anonymous delegates using lambda expressions. So descriptor.structure, we're going to now do this for the rotation. Transform rot and a game object dot transform dot rot equals A. So this is now going to save the position and the rotation for this object. So I'm going to do a compile, and it should compile successfully. It does, and we're done. So now when we run this object, it's going to create this database in the background. So right now the file is empty, so when I run it, it should pop in here with the database. So here's the basic database that we created, and it's writing out 47 bytes at a time. So now what I said that it was going to do is remember its location. So I'm just going to move this over here and move it down here. Now I know it's going to save the rotation, but I'm just going to pause it and play it back again, and you'll notice it pops down to this location. And I mentioned before it's going to save the rotation. So I'll just change the rotation slightly, exit, and start again, and now it's moved and the rotation has completed. And that's all you need to do. Pretty simple, straightforward kind of script. Watch it again to sort of see how it all works, and we'll see you in the next video. Thanks.